Thanks. So thanks for persevering here. So I'm Guy Podjarny, and I will talk to you today about secure JavaScript code. And we'll do some live hacking, and it will be fun. And hopefully that was the last sort of technical hiccup going on, because there's live demos, so there's high propensity for flaws. So a little bit about me is I indeed sort of spent a good chunk of my time in the world of security, sort of through the Israeli army and through the sort of first segues into the world of application security when we had to teach people why SQL injection matters and cross-site scripting matters, and then took that detour into performance for about 6 years, most recently CTO at Akamai, and then back into the world of security, dealing with open source security now, which I'll talk about a bit more. So digging into it, into the depth of the talk, we all, I think, agree JavaScript is awesome. It's also terrible, but it's also awesome. And we oftentimes like to talk about how JavaScript has won, like in all these sort of adoption metrics and all of that. And there's a lot of reasons to it. And there are these like notable JavaScript traits going from just sort of the scripting capabilities like the dynamic typing and built-in memory management, just sort of less effort to get going, some good API-related capabilities like the JSON friendliness where you can just pull that in. There are a lot of templates and sort of scaffolding for us, so we don't need to reinvent stuff. It's isomorphic. That's probably one of the key success reasons for Node.js, so you can run it on the server or on the client. It's both sort of skill set relevant, but also sometimes you can run the same piece of code in both. And of course, it has the flourishing NPM package ecosystem, which is also growing by leaps and bounds. But when you put the paranoid hat on, sometimes what makes JavaScript awesome is also what makes it vulnerable. So as a security person, I look at it and I see all these like notable traits, and each of them feels like a potential flaw, right? It feels like an area where there might be a problem. You talk about built-in memory management, but whenever that deviates, for instance, through the Node.js buffer object, you might get remote memory exposure. You look at native serialization with JSON, so you can just take an object, serialize and deserialize it, and I think about type manipulation. Can you turn a string into an integer or an array and play around with the app, and so on and so forth. So there's a whole set of these flaws, and we need to make sure that we understand them. We don't talk a lot about them, so I'm going to be talking a lot about them now. The second thing to keep in mind is that while we're going to talk about these vulnerabilities, it's not always your code that is the problem. NPM is also awesome. I mean, bar is dead, but NPM is awesome, and it is growing by leaps and bounds. And I've kind of gotten fed up with updating this slide. So it's about a month old. It has 540,000 packages, some gazillion, billion downloads a month, and just growing by a ridiculous pace. So it sort of gets to the situation where a typical Node.js app has hundreds, if not thousands, of different different dependencies that power it. And similarly, on the front end, we see NPM powering React and Angular and Webpack and a lot of the modern front-end JavaScript stacks. So you get to a point where this is your app, and this is your code. I like to say that like this seems like a negative slide, but I see it as a positive one. It means all you had to do is write that purplish little amount of code, and you got that orangish value, right? Just now, even like when hacking coffee machines, there's libraries that you can use, and they help you. They help you do more. But it's also a concern, right? Sometimes it makes you go from thinking JavaScript has won to JavaScript has won in a slightly more exasperated tone. So when we think about security, we should remember that since most of your code comes from these NPM libraries, to a large extent, most of your vulnerabilities, most of the security flaws also are embedded in those codes. This is a real-world problem. In the world of NPM, roughly every 7th library carries a vulnerability, so either in its own code or in a dependency that it's pulling in. And the vast majority of apps would be using such a vulnerable library until you actually start testing for it. And this risk sort of spans the world of JavaScript. It actually technically spans beyond the world of JavaScript. I'm just going to focus on it here. And it risks node apps, front-end apps, isomorphic apps. Sometimes the same security mistake that happens on the server would be more maybe concerning on the client or vice versa. And of course, IoT apps, right? I could hack maybe that coffee machine. I'm sort of thinking to go to Johnny 5 and run a little quick test to see which dependencies it's using. So this is kind of the concern. What we're going to do today is we'll take advantage of the fact that these libraries may be vulnerable and also try to use them as examples, because these are public vulnerabilities in open source code that we can see, we can learn from, and we can try to avoid these types of mistakes in our system. So what we're going to do for the rest of this talk is we will show a demo application, and we'll find some vulnerable libraries on it, and we'll exploit a handful of those vulnerabilities so we can see how that happens and what's the implication of it. And of course, talk about what was the mistake and how can we avoid it. And then we'll talk also about vulnerabilities in the dependencies, talk about securing those. So with that, let me switch off this keynote here. I think I'm going to take another risky move here with the display and try to mirror. Otherwise, I'm going to be doing a lot of this. Let's see if that happens. Arrangement, mirror. Woo! Okay, I think it's working. I hope I didn't mess up any resolutions there in the back. And we're going to move to the browser. So we've got a little to-do application here because, it's a demo app, so of course it's to-do MVC. You can add things like, call mom, sort of a to-do application deployed on Heroku. I'm relying on internet. I think it's just my Heroku app waking up. You can emphasize important things. You can, use a bunch of capabilities with Markdown. And, this is just sort of a simple application. It is on GitHub. I can sort of tweet the link after that. And it's just a simple vulnerable application. So this application, just shortcutting a little bit for the sake of time, it uses a bunch of dependencies. This is the view from Snyk. Kind of full disclosure, I'm going to use Snyk for it for demonstrating the concept. This is the kind of company that I work at right now and what I deal with. But it has a whole tree of dependencies, not an unusually big one. And some of those dependencies have vulnerabilities. We're going to pick on a bunch of those vulnerabilities. So we're going to start with Marked. Marked is, anybody here heard of Marked? A few hands. So it's a fairly popular Markdown parsing library, and we use it to do that, sort of emphasize alcoholic beverages we like in our system. And it has a vulnerability that typically you would read about here, but you have me, so you don't need to. I can demo it. So it has a cross-site scripting vulnerability on it. If you think about a component you know it has cross-site scripting vulnerability, what are you going to try and do? What's the sort of first probe for security for cross-site scripting? An alert. So you're going to try something like this, alert 1/script. And if I do this, nothing happens. Cross-site scripting is not as simple as you might think. There are a lot of variants, like a zillion variants, and all sorts of permutations. I can go in here and put an image tag with an onload. I can do a lot of those components. I can spare you that time and tell you that none of them would work because Marked has a really good sanitize function that catches almost all of those cases. Annoyingly, it is not on by default, so you would need to turn it on, but I did turn it on in this case. But it misses something. So as a part of the HTML tags, it catches all of those, but Markdown also allows for links built in. So I can do something like snyk.io here, and click this, and it would open up a link to here. So that's fine. That's not a problem per se. That's a link. But if I have this, and I know there's a cross-site scripting vulnerability here, what would I try to do? JavaScript. So I will do JavaScript alert 1. And then I would do this, and ooh, hold on. Live coding here. JavaScript alert 1. And nothing will happen because sanitize would catch that as well. So I can take you down a long and arduous journey here where I would go to an encoded version of it. Anybody remember by heart the HTML entity for colon? 58. Shame on you. And then I will put like 41 here because I know that I need to as well for encoding that brackets. And I will do this, and this is getting fancy, and nothing will happen. So I think what's interesting here is, actually Marked is perfect, down to the spec. Browsers, however, not so much. Much more permissive. And what happens if I do this? Literally this. So I added some text here. The browser comes along and says, well, you told me you have an ampersand, you have a hash mark, you have 58. Yeah, you forgot the colon, but I got you, and I know what you meant. You meant a colon. It's okay, next time remember, but this time I will put a colon here. So when I do this, everything else is just JavaScript. And indeed, I would get that alert. So the reason I take you down sort of this journey is just to say vulnerabilities are complicated, And coding is complicated. Different inputs are complicated. And it's not a fault or shameful behavior for somebody to not consider all of those permutations. There are a lot of changes, and they change all the time. So lesson number 1 is be wary and marked. By the way, it has a different vulnerability in data URIs. So you can also provide a data URI in here that would also allow you to inject a script. But also, just in general, one lesson we can take from this is that encoding is a problem. This app also has a vulnerability in a package called ST, which serves static resources, that has a URL encoding vulnerability, where you can force browse your way out of it. I'm not going to show all the exploits on this hack because I don't have time, but you can play with that afterwards. So maybe lesson number 1, encoding. Beware encoding. Try to sanitize your input and kind of do your verification on the decoded string always, or just disallow encoding. Part 2, let's talk about another vulnerability. So in here, if I look at this, there's another popular package here called MS. Who here has heard of MS? No? Who here has heard of Moment? Yeah, so MS and Moment are kind of the same. MS gets downloaded about, just a small number of about 40 million times a month. You use MS, you just don't know it. It's a child dependency of many other dependencies. This is a common occurrence. Very, very popular packages. The most popular packages on NPM are actually not used directly as much. They are just dependencies of your dependencies, or maybe dependencies of your dependencies of your dependencies of your dependencies, and these trees get big. But they might still introduce a risk to your own application. So MS has a Redose vulnerability. Redose is an interesting one. Let me show you and then explain it a bit more. So first of all, we use MS for a little memory here. What it does is it allows you to convert time durations into the number of milliseconds. So I can say call mom in 2 days, because that's frequently enough. And it would remember that 2 days, and it would remember it in milliseconds, and I can play with that now in my app. So now that I have this milliseconds, to do that type of parsing, it uses a regular expression. Now, you don't think about regular expressions that way, but regular expressions are algorithms. And algorithms may take a while to run, depending on how they run. So let's see this happening. We're going to move off the browser, which is not a great hacking tool here. And we will use, I have some shortcuts here, just the command line to run these tools. So first of all, we're going to run the same thing. This is a little bit more optimistic. Call mom in 20 minutes. And if we go back to our application, we added a little call here. Nothing really happened. We just used curl, or rather HTTP-PY, which is just a curl with syntax highlighting, to run this test. Maybe I'll move this up a little bit here so you can see it a bit better. So, but what happens if we make that 20 be a very, very long number? So I happen to prepare one of those. So maybe I will do this. So I will run 60,000 fives on sort of my request to add milk, and we'll see what happens. And this would now trigger a very, very long string that is coming into a regular expression. And regular expressions are state machines. They maintain these states around the possible matches that you might have to a string. And as a result, they typically will take a non-linear amount of time to the length of the string. If your string is 10 times longer, it's quite likely it'll take more than 10 times longer to process that string for the regular expression. So if I send a very, very long string, it may take a very, very long time to process. So if I do this, it actually completes fairly quickly. If I go in here, I'll see that it's at infinity because it messed something up. I will never buy milk. But it completed fairly quickly. The catch is that regular expressions take the longest amount of time when they do not match. So if I take this string here and I take this S and I swap it with an A, so it doesn't match. It gets all the way to the end, and then it's missing that last character to be a timestamp. Now, it'll take a while. And if I go in here and I try to invoke or run anything here, nothing will happen. So a few things. First of all, the regular expression is taking a long time to run. And because this is JavaScript, because this is Node, it is running on the event loop. So the event loop is a great capability in JavaScript, and it's, again, one of its claims to fame. It's naturally scalable because a single thread can just serve many, many clients and just go asynchronous on everything, right? As soon as there's I/O, it's asynchronous. And therefore, a single thread can support many, many, many different clients. However, that single thread is a single point of failure. So if I can run an algorithm for a long period of time, it means I take down that thread and with it many clients that it might serve. Maybe unlike another environment where I would also care about losing threads, but every thread would lose a client, so I would need to repeat that many, many times. Now, eventually this kicked in. If I added a 0 here, we would just be sitting here waiting for this to happen. But remember that the event loop is a fragile entity for us. You need to be aware of long-running algorithms, and the algorithm that you don't think of that way but is an algorithm that you run most often is a regular expression. So you need to especially be aware of that. Let's go back to the deck a second and look at this in a bit more detail. So this is another more simple regular expression. It says A, and then B or C, one or more occurrences of C, and then that whole group of B or C may happen 0 to infinite times. It's a fairly simple regular expression, and sort of a naive view of it would say it shouldn't be hard to process. But what happens here is this C is tricky. If I take the first chunk of characters there, the engine would see A and then C. Okay, so the C is in that group. And then it sees another C. Does that C relate to the plus, or does it relate to the star? I don't know. It'll pick one, and it'll go down that path. It'll go all the way to the end just to find out there is no D at the end of that tunnel. So it would backtrack. It would backtrack one step and try again. When you have these types of nested options, when there's multiple options that could allow sort of an exponential amount of these states, that's referred to as catastrophic backtracking. It would need to go all the way back to the end, and then just every permutation of two C's can now fit into another type of these paths. So catastrophic backtracking is not good. It's in the name. It's a catastrophe. And it is not the only case in which Redose could happen, but it's one of those cases where a very, very small number of characters might cause this. Moment has a different vulnerability that has been fixed in a newer version that indeed can be triggered with about 40 characters because of this type of catastrophic backtracking. Maybe I should switch my examples to be on Moment. Cool. So far, so good. So lesson 2, beware long-running algorithms on the event loop, and specifically beware Redose. The third class of vulnerabilities I'll talk about today is type manipulation. I'm going to start in slides, and then, you know what, I might have time to actually show this, this live. So, sorry, one more. It's a good thing I have slides. One thing to remember about Redose. So if you do this type of long-running script on the browser, on client-side JavaScript, you're going to get that fun screen that says the script is long responding, and you're going to DOS a single client, which is not a big deal. However, JavaScript is isomorphic. So if you allowed for that script in certain contexts to run on the server, for instance, maybe you render HTML in your Angular app to search engines, you want to render it on the server and run it, and you might have a Redose like this, because you get some parameter in the query, then it means an attacker can fake a request with the Googlebot user agent and would now take down your server. So in the world of JavaScript, isomorphic makes every client-side vulnerability potentially a server-side vulnerability as well, and you have to think about that. You have to consider it. And from what I have experienced, and sort of for the organizations I work with, I can see that isomorphic is a very, very common example. You think of isomorphic as something, hey, I got fancy with my performance and I'm running some piece of JavaScript on the server and all that. That's not common. But what is common is just for these search engines that I don't think know JavaScript, I would run or render my page on the server, especially if it's a JavaScript framework-based page. And that is common, and therefore you would run that JavaScript, that sort of cross-site scripting or that Redose on the server side, and it might turn into a remote command execution or into a denial of service. So now actually switching to type manipulation. So this is a simple piece of code that is used for a NoSQL account verification input, right? Somebody comes along and they want to log in. You take their username, you take their password, and you look up that username and password, hopefully a hash of this password, in the database. And it returns a result. If this was an SQL database, then you would say, this would be some query, right? Select star from users where username equals something and password equals something, and you would worry about SQL injection. Who here has heard of SQL injection? Okay. Who here has heard of NoSQL injection? Not as common. So NoSQL injection is NoSQL, but still an injection. So let's say I have this scenario. I have an admin and a super secret password that I'm using. This is on this app, but I don't have time to sort of show the exploit. Again, you can go to that sneak/goof demo app and run these exploits yourself. So when I do this, that's cool. It goes, it logs in. But because but what you might not know is that while NoSQL databases typically would get values, almost all of them allow operators as well. So what I could also do is pass this. So to the password, instead of passing a value, I would pass an object that says greater than 0. And this is a lookup capability, and all databases work. This specifically works on Mongo, but all NoSQL databases support some form of slicing like that, some lookup of categories. And you know what? Let's sort of see this very, very quickly after all. Might be stretching time a bit for it. So on our awesome app, we also have an admin section, which allows us to put these types of controls. And again, we're going to go here to the client. And we're going to curl. And if we go back a little bit, we see that we got admin access granted because we used our super secret password, right? Let's make one tweak to this and say, use JSON as input. Now, this is very, very common. It's common in many apps today, but it's especially common in JavaScript, where you use JSON and you say echo just a different form. Instead of a form field, I am passing a JSON object in here, and I'm providing a name and a password in that fashion. And most kind of modern apps would support some form of API, and many of them would just take this object and deserialize it as is. Now, if you happened to deserialize it like this, first of all, maybe just to show you I'm not cheating here, this is an example with the wrong password. If I run this, then I will just get back to the admin access page. I'm not going to get the granted. But if I do this, I can provide this JSON and provide a different type of object. Instead of a string, I make that JSON now send an object back. It'll get naturally deserialized in my application, passed on to the Mongoose client, and et voila, or not et voila yet, here we go, et voila, admin access granted. So it's a big deal. It's as big a deal as SQL injection, just not quite as flexible as it, but it's something to be aware of. And it comes down to the fact that I've not checked that the type of the object that I passed along is indeed of a string as I expected. If I had vetted that, this would not make it through. But while we're fairly familiar with comparing it for strings, if you just did a compare to that object, you checked if it had some characters in it, JavaScript would conveniently convert it to a string and allow you to check and see that it doesn't have whatever, an escape quote in it. But if you just allow it through, if you don't explicitly check for it, you wouldn't find out that it's not of type string. Just for the heck of things, you can actually even enumerate the username, right? I can just do this and say, give me the first user, the first password, and again, I'll get in. So, not good. Beware type manipulations. Let me show one more example of type. So JSON is one way in which I can manipulate a type. There are a bunch of others. One other very, very common way in the world of JavaScript is QS. You're familiar with QS? Who here is familiar with it? No? Who here is familiar with Express? So like anybody familiar with Express is using QS. QS is the query string parser that is used by request, that is used by Express. It's basically the tool that is being used for parsing query strings. And it's very convenient. It takes, if you parse this type of string, you would get an array that says, or sort of an object that has an A field and a B field. But if you do this, you have A twice, then it needs to somehow model that, and what it would do is give you an array. Similarly, if you did A square brackets something, it would give you an array. So convenience, not a problem per se, but what I've just shown here is a manipulation of type that might not be obvious. If I go back to my vulnerabilities over here, at the very top is probably the worst vulnerability of this application. So DustJS is a reasonably popular templating library created by LinkedIn, used by PayPal and many others. I think it was one of the first to really do server-side rendering well. I think they sort of made a lot of noise around that then. And it has some conditions that it can run that omitted the need to check for type. Like they did proper sanitization of all the different characters. So if you passed a string, you couldn't really break out. But if you passed a non-string object, it would skip the sanitization. And somewhere down that stream was an eval lurking. So what happened was that throughout this path, if you provided the right string, you could actually get the server to execute code. And this was found on the PayPal website. So to demonstrate this, I'm going to show this on our new About page. So we have a really good About page for the site today, but we have an even better one coming. You might not notice this, but this is a mobile-first design. You can add device equals desktop to get the desktop version of it. This is the extent of my CSS skills. So it's a very fancy one. So there's a condition there in that DustJS template that says if desktop equals. So let's play with this a little bit, right? So we have, once again, we'll go to our browser. We'll do a little curl here to just request device equals desktop. So we're asking for this string, and we'll get our little new awesome About page. Let's start playing with it a little bit. So we can do, in Dust2, we can start, first of all, we can change the device string to be an array. And that would, in return, it's going to be a little bit hard to show it here. Oh, sorry, what did I do? I'm just going to run Dust2. You might not see it, but it'll basically return the mobile version of it, because now it's no longer something that just equals desktop. I can go on and try to play with Dust3. And what I'm doing here is I'm adding a quote, a single quote. So I'm breaking something here. And if I do this, I get an error. So this is this is the type of flow that an attacker would go through. They're trying to get something that is different, something that might break, and then there's a difference. This input was interpreted differently than the previous input. You can go on to say, maybe run some curl that takes that single quote and then adds some JavaScript action, dash console.log, snick was here, blah, 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 right? I can run this. Now, this is really fancy, and I got JavaScript to run on the server, or I didn't. I don't really have access to the console log of the server side, and all I've done is leave a footprint. That's not very good. As an attacker, what I would do is something like this. I would stand up another server somewhere and put a little listening port over here. And then I would do a slightly fancier command here, which is I will require child process, and then I would execute a command that maybe would curl the etc passwd and send that over to my server. So if I do this, and over here, we got the etc passwd. Not very good. So this is another variant of type manipulation, and yeah, not awesome. So let's kind of wrap up, right? First of all, don't go starting hacking website. It's illegal in most countries. It is definitely not polite in any. What you can do is you can go off and fork snake/goof and play with that on your applications. That's sort of there for you to play with. We have JavaScript takeaways, and then we have dependency takeaways. So from a JavaScript takeaways, we talked about just a set of these problems. I've got a 50-minute version of this talk that sort of exploits a few more. But you should be wary encodings. We talked about those. Be wary of long-running algorithms. And then think about type manipulation. Type manipulation is a whole plague onto its own. It's an attack vector. There are different types of vulnerabilities that would be manipulated via type manipulation. The second thing is that keep in mind that all of these vulnerabilities existed in my system without me writing any of them. I just used libraries, well-known, popular libraries that had a bug. Libraries have bugs. It happens. Everybody has bugs. And those bugs were actually fixed. All of these libraries, maybe Marked has one that's not yet fixed, have fixes to these vulnerabilities. But how would you know about it? You need to know explicitly, look to see if those libraries have vulnerabilities. The default action is you don't. You just use this library, and it just works, and you forget all about it. So the first thing you want to do is you want to find these vulnerabilities. So we've shown how you can do this with Snyk, or at least we've shown our report with Snyk. I'm biased, but I think it's awesome, and you should use it. Just this last week, Microsoft Sonar, for just for front-end JavaScript libraries, the jQueries of the world and all of that, has introduced Sonar as like a linting tool that they just launched that has a bunch of capabilities, including the ability to test for vulnerable libraries. It actually uses the Snyk database in the background. It's just for the front-end libraries, so it wouldn't find Marked and the likes, but it would find cross-site scripting in jQuery or some flaws in Angular in wrong versions, etc. So you should use it. And then also, actually, last week, Lighthouse in Chrome DevTools that was mentioned this morning. So Lighthouse is Google's auditing tool, and it's now integrated into Chrome DevTools. And in Chrome Canary, this type of test is already embedded into it. So Lighthouse independently and in Chrome Canary, and soon in Chrome itself, it would also test for vulnerable libraries. This is only for the front-end libraries. So I'm really, really happy this is happening. We're working with them to make it happen. They're sort of using our database for it. But don't stop here. Once you found them, you want to fix these vulnerabilities. The easiest way to fix them is to upgrade. So many of them would have an upgrade, so try to do that. I'm a little bit over here. If you cannot, for Snyk specifically, we have patches you can consider. Don't want to pitch too much here. You can explore those after that could patch the vulnerabilities or sort of help you open these fix pull requests automatic that just sort of give you the minimum upgrade necessary. Kind of plug aside. Once you've found and you fix the issues that you want to stay that way. You want to stay vulnerability free. So the next thing you want to do is you want to prevent the addition of new vulnerable libraries. You can do this via breaking the build when there's a new vulnerable library with the tool of choice that you want for doing that find. So run that same find action, but in your build. Or you can do it through a pull request test, which is a little bit more refined. It just tests whether this pull request specifically has introduced a new vulnerable library. And then lastly, this is where quality analogy maybe breaks. You have to be alert to newly disclosed vulnerabilities. Equifax was just breached because a new vulnerability in a library that we're using, struts2 in Java, had a remote command execution, and they did not know about it quickly enough. They did not fix it quickly enough. So think about how would you find out about these vulnerabilities, and how would you be equipped to fix them and address them quickly before the attackers come along and exploit that vulnerability. So that's it for me. JS and NPM are awesome, but please enjoy them responsibly. Thank you.